Hello everyone. Today is lesson 8.6. Today is day 1. Radical expressions and rational exponents. Miss Boyd is busy helping out with AP testing, so she is unable to be with us today. The essential question is, how do I simplify radical expressions? Who can use this? Well, guitar makers use radical expressions to ensure that the strings produce the correct notes. Quite interesting. You are probably familiar with finding the square and square root of a number. These two operations are inverses of each other. Similarly, there are roots that correspond to larger powers. So 5 and negative 5 are square roots of 25 because 5 squared equals 25 and negative 5 squared is equal to 25. 2 is the cube root of 8 because 2 cubed is equal to 8. So I'm right here right now. 2 and negative 2 are fourth roots of 16 because 2 to the fourth is 16 and negative 2 to the fourth equals 16. So as you can see, when you have a negative number and you raise it to an even power, your answer becomes positive. That's very important. So right here, a is the nth root of b if a to the n is equal to b. I'm going to see if I can use the highlighting feature. I'm using a different, yes, oh, that's not the highlighting feature at all. So we're going to cross that off right now, and we're going to go and try that again. No, the highlighting feature is not going to work for me. So that's all right. This is a new slate that I'm trying out to see if it works. And it works, it just doesn't let me highlight. Okay. So a is the nth root of b if a to the n is equal to b. That's important. We're going to go over examples. So now let's go over some terms. If you look right here, I'm going to circle this right here since it's not highlighting for me. A is called the radicand. N, so here, so A, I'm going to write over here, A is radicand. N is the index. You need to memorize that because I'm going to use that a lot in class. A is the radicand, the number under the radical, N is the index. The table here is very important. We're going to use it today. If your index is odd, you will have one real root. If you have an even index, 2, 4, 6, 8, and a positive radicand, the number under the radical is positive, you're going to have 2 real roots. If you have an even index and you have a negative radicand, you're going to have 0 real roots. That makes sense because, for example, the square root of negative 16, that is equal to plus or minus 4i. And so if we were solving something like that, if we have obviously x squared is equal to that, take the square root of both sides, yeah. So plus or minus 4i, that's not a real root, that's why that's 0. When you have a radicand of 0, there's one root and it's 0. Now I'm going to scroll down here. Underneath our picture, it's in your notes, but it says, when a radical sign shows no index, it represents a square root. Next page. Here we go. Example 1, find all the real roots. So here it says the 6th root of 64. So 6th root, well, that is a 6, obviously. So therefore, we have a positive radicand right there and an even index. When you have a positive radicand and an even index, you're going to have 2 roots. So remember what we just talked about. We said a to the n is equal to b on the last page. So therefore, we know that we're trying to find what number raised to the 6th power is equal to 64. Okay, so therefore, the answer is going to be, you can actually type this into your calculator. You can try to, or excuse me, you can take actually the 6th root of 64 and you're going to find your answer. So for example, we know that 2 to the 6th is equal to 64 and negative 2 to the 6th is equal to 64. So it says find all the real roots. There's going to be 2 real roots and the real roots are going to be 2 and negative 2. So that is going to be your answer right there. B. Now notice we have a, this is negative, and cube is 3. So we have odd with a negative. Remember, that means there's going to be one real root. So we're going to write a, what number to the third power gives you negative 216? Well, we know that, again, you're going to use your calculator, and I'll show you in class. Negative 6, if you raise that to the third power, that is going to equal negative 216. So the root is negative 6. Only 1 on that one. So up here, we get 2 real roots on A and 1 real root on B. C, fourth root of negative 1024. So 4, and we have a negative. So what number to the fourth power is going to give me negative 1024? Well, guess what? Nothing. When you raise any number to an even power, you have to get a positive, and we're not going to get a positive. So the answer is no real roots. That's it. I'll circle it. There we go. Example 2, we're going to save for class. Next page is, all right, we're on to this. Properties of nth roots. So for a greater than 0 and b greater than 0, here are some properties. The product property of roots and the quotient property of roots. So what that's saying is, when the index is the same for two numbers under a radical, right here, you can multiply them together and get this, or break them apart like they're doing here. That's the property. This is the property right here, and dividing is the same thing. If the index is the same, you can divide them and manipulate. So let's just do some examples. When an expression contains a radical in the denominator, you must rationalize the denominator. To do so, rewrite the expression so that the denominator contains no radicals. We've done that a ton, and I will show you an example. Let's do the first one, example 3 right here. Simplify the expression. Assume that all variables are positive. So what we have to do here is, because our index is a 4, we are going to separate this, what's underneath the radical, out into groups of 4. So what I mean by that is, we have to think to ourselves, what number raised to the fourth power is going to give me 81? So you could go to your calculator, use the fourth root button, plug in 81, and you're going to get an answer, and it's going to be 3. So this is how we write this out. Okay, so I'm going to separate this out, just like we did in the properties above. They broke 16 up into 8 times 2, the cube root of 8 times 2. So we're going to do the same thing here. So we have the fourth root, that has to be out there, that's our index. 3 to the fourth is 81 times. Now I'm going to break up the 12. We know, let's review something. I'm just writing something down here. We know that x cubed times x squared is equal to x to the 5th, right? When you multiply two bases by the two bases that are the same, you add their exponents. So we're going to break x to the 12th up into groups of 4. When I say groups of 4, you have to start with x to the 4th, because it has to be the same as that. If the index was a 3, I would start with x to the 3rd. So how many x to the 4th am I going to get? Well, we know x to the 4th times x to the 4th is x to the 8th. So I have to keep going. Times x to the 4th, that is going to be x to the 12th. So x to the 4th times x to the 4th times x to the 4th is x to the 12th. We're good. Now watch now this is my favorite part of all. Because the index and the exponent are the same, in a sense what happens is they cancel, and then the number comes out. Same thing here. They cancel, and the variable comes out. And the same thing happens here. And the variable comes out, and here, and that comes out. You don't have to cancel them if you don't want to. You know that when the exponent and the index are the same, they cancel, and what's under the radical comes out. So 3x cubed is going to be your answer. There we go. Next page. Let's see here. Let's see if it just goes to the next page. Yes, it does. I'm looking at that one. I'm just seeing what all I have left to do here. I am actually going to save this one for class. And example 5, I think is on the next, no, I missed example 5. Trying to scroll down and it's not letting me scroll down right now. There we go. Example 5. That is actually pretty straightforward one, so we're going to save that one for class 2. And we're going to go here. And this one, we're going to go through this one right now. Okay, so what we have here is we have a division one. So I have to go through this because I didn't go through one yet. So right now, based on the property, I'm going to break this up into 2 separate radicals. So we have x to the 8th to the 4th root over the 4th root of 3. You have to do that number 1. So now what we're going to do is I'm going to move down here because I need some more room. So I have an 8, different color. As you can see, I have an 8 here. So I need to break that up into groups of 4. They have to be the same. So what I'm going to do, I'm going to write a 4, and I'm going to start with x to the 4th again. Remember what the index is? You want the exponent to be. And I'm going to need 2 of them. X to the 4th times x to the 4th is x to the 8th. So we're good there. And on the bottom, we still have that. I can't break the 3 up. I can't do anything with that right now. Well, let's finish up with the top here. I know that the x is going to, these 4s are going to cancel, right? We already talked about that. So that these 4s will cancel and these 4s will cancel. And what comes out is an x times an x over a 4th root of 3. Well, that's just x. Hold on a minute. Try it again. That's going to be x, there we go, squared over the 4th root of 3. Can't leave a root on the bottom. So therefore, what we have to do is we have to multiply, well, think about it. We have to multiply the bottom in order to get this to cancel. We have to multiply the bottom by 4 different cube roots of 3. So if I do that to the bottom, guess what? I have to do it to the top. So I'm going to do the same thing on the top. Just changing my color just for the fun of it. And we're going to do, and, okay. So now I'm going to jump down here. I have x squared, and I have 3 times 3 times 3. That is 27, 4th root. And what happens in the bottom, we have 3 times 3 times 3 times 3. Well, that's 4 3s. So what's going to happen is, a lot of you are going to skip this step, but I want to show you, that's 3 to the 4th to the 4th root. So I know those are going to cancel, so the 3 is going to come out. So then our final answer is going to be, erasing this so I have some extra room here. Sorry, there we go. We have x squared, and 27 is under there. And the 4th root, you got to write that there, all over 3. And that is not a negative. I'm going to write the answer over here so because that looks like a negative 27, and that's not supposed to be. 27, 4th root, over 3. That is your final answer. X squared, 4th root of 27 over 3. Kind of tricky, but you'll be fine. We're going to do this one in class, and there's your video question for the day. Simplify each expression, assume all variables are positive. You can do that one, and then the one next to it. I think you're going to be very capable of doing that one too. It's similar to the one I just did for you with you. Have a great day. See you tomorrow.